In this video, we're going to look at some more examples of working with our polynomial functions. And the first example that we're going to look at is the function f of x equals x to the fourth minus x cubed minus 30x squared. And here we want to graph this function by finding the zeros and using the information we talked about before, knowing the total number of turning points are your relative max and min, and looking at the multiplicity, where does it cross the x-axis and where does it only touch the x-axis. So let's see what we can determine here. If we start off with our leading coefficient test, for example, then we know that the graph, and we're just going to kind of estimate and make some guesses here. We know that the graph, because this is even, x to the fourth, we know that it's x squared, both go to the upright and up to the left. So here this is a positive x to the fourth. So again, we know the ends of the graph are both going to be pointing up this way to the left and also up to the right. All right, so if we go about finding the zeros, then we're going to simply set the function equal to 0. And if we're going to solve this, we can easily factor this. All three terms contain an x squared, so we could certainly factor out the x squared. And we're left with x squared minus x minus 30. And if then we can factor the x squared minus x minus 30, that would simply factor to x times x, gives us the x squared. And for 30, what are the factors of 30? Well, we have, what, 1 and 30, 2 and 15, 3 and 10, 5 and 6. So which combination here is going to give us the negative 30, but also so that they add together and we get a negative 1x in the middle? Well, because we want a negative 1, I'm going to go with the 5 and the 6. So 6 times 5 is certainly going to give us 30. And because it's negative, one of these has to be positive, one has to be negative. And because we're looking for a negative 1x, the 6 has to be negative and the 5 will have to be positive. So now we have factored this completely. We have our three factors, so we're going to set each factor equal to 0. Now don't forget the x squared, we also set that equal to 0. X minus 6 is equal to 0, and the x plus 5 is equal to 0. So here we have x squared. Now notice this, we have x squared equals 0. This is giving us that repeated 0, so we have a multiplicity, the multiplicity here where k equals 2, so we have an even repeated 0. That is x equals 0, and then we have x equals 6, and x equals a negative 5. So here we have our zeros. We have a 0 at the origin, at x equals 6, and I'm just going to mark this here as 6. And we have a 0 over here somewhere at a negative 5. So there we have our three zeros. And remember, we talked about this here being x to the fourth. We would have at most 4 real zeros. Okay, that's the most we could have. Well, in this example, we have 3. And we know that our graph is going to come down, and at negative 5, our graph is going to come down and it's going to cross through a negative 5 here somewhere. Okay, and then eventually the graph is going to come back up and it's going to touch at 0. Now what's happening here at x equals 0? Because of this even multiplicity, it's going to come up and it's only going to touch at 0 and come back down. And then eventually the graph's going to have to curve and it's going to go back up through the 0 at 6, because we know the graph is then going to continue to go up. Now that's all that we really know. We don't know how far down this graph is going to go. It may go down really far. It may just simply curve up. And again, over here, we don't know how far this is going to go down and come up, or it could just be a quick little turn here. But we know basically the graph is going to look very similar to this here. Now, if you go and put this into the calculator, you're going to find out if you finish graphing this, the graph of this is going to be kind of a short little curve here. It's not going to go down very far. But then you're going to notice over here, this point is going to go down really far and then come back up. So if you try to set this up on your calculator, you're going to have to make your y minimum down here. It's going to have to go down to, I believe, a negative 300. So you're going to see your graph's going to look very similar to something like this if you finish graphing this using your calculator. Or you could do it by hand by plotting points, but because we have the calculator, you could finish this by using the calculator. So here we have our zeros, 0, 6, and negative 5. And just kind of as a reference then, what are going to be our factors? Well, the factors then would simply be x, x minus 6, and x plus 5. And again, because we had this repeated, you could think of this as x squared, x minus 6, and x plus 5. All right, so hopefully by now you're getting the hang of finding the zeros and determine whether the graph's going to cross the x-axis or only touch the x-axis. The next example here, we're going to look at going in the other direction. You're going to be given the zeros of your function, and we want to find the function f of x. So if you're given the zeros, let's say that we're given negative 2 and negative 3. We want to come up with a function that has these two zeros. Now, I'm going to actually quickly over here to the side, I want to kind of think of if we have a function x squared plus 5x plus 6, and we set it equal to 0, how do we go about finding the zeros of a function? Well, we certainly factor the function. So we would have x, and here for 6, that's going to simply go to 2 and 3. We want a plus 5, so it's going to be plus 2 and plus 3. And then our next step is we take each factor and we set it equal to 0. And then we simply solve each one for x. So we get x equals negative 2 and x equals negative 3. Now think about the steps we used here. And we want to think about working backwards. So I know we've kind of worked this problem out, but if over here we have a negative 2 and negative 3. So if we think about starting here first, our first step is we're going to take each 0 and set that equal to x. So x equals a negative 2, x equals a negative 3. All right, and then if we move up here to our second step, we're going to set each one equal to 0. So over here, if we're going to set these equal to 0, then that means we have to add the 2 over, so we get x plus 2 equals 0. Add the 3 over, you get x plus 3 equals 0. And then over here you have your third step where you're going to have your factors multiplied together. So that means we're going to take the factor of x plus 2 and x plus 3. And then we simply multiply that out. So x times x is x squared. And once we multiply x and 3, that's going to give you 3x. This is going to give you 2x. So 3x and 2x is going to be 5x. And then 2 times 3 is going to give us the 6. And here we now have our function. So really you have to kind of think about working backwards of what we did over here when we were solving for the zeros. All right, I'm going to give you an example and see if you can come up with the function. So we want to have the same exact problem, but now you're going to be given the following zeros, 0 and negative 4, and you want to find a function. And I could be specific and say we want to find a function f of x that has these zeros, that we have a degree of 2. Well, when we say we have a degree of 2, that means we want the exponent, the largest exponent, to be 2. Well, if you want to pause the video, you can try to work this out on your own. So here again, we're going to start and kind of work backwards. We're going to take and set x equal to 0, x equal to negative 4, and then we're going to set each one equal to 0. Well, the first one's already equal to 0. X equals negative 4, we have to move the negative 4 over, so that means we're going to add 4. And then we're going to take each factor and multiply them. So we have x, so that's going to be x times x plus 4. And now we're just simply going to multiply these out. So we distribute the x. If we distribute the x, x times x becomes x squared, and x times 4 becomes 4x. And there we have our function with a degree of 2 that will have the zeros of 0 and negative 4. So there's your function. All right, we have one more example that I want to look at, and this one's going to be a little bit involved here. We're going to be given the zeros again, and this time we have negative 3, 1, and 2. And we want to find the function f of x, but this time we want it to have a degree of 4. So that means we know we're looking at having a possibility of 4 zeros. Now, if you notice here, we're looking at a degree 4, so we want to have eventually a x to the 4th in our function, but we only have 3 zeros. Well, that means that one of these zeros must be repeated. Okay, so once again, if we start out the same process, then we know that we have x equals negative 3, x equals 1, x equals 2. Set each one equal to 0, so that means we're going to have x plus 3 equals 0, x minus 1 equals 0, x minus 2 equals 0. So then we're going to multiply each one of these together. So you'd have the factor of x plus 3, x minus 1, and x minus 2. Now, this here is going to give us our function. But notice this function, if we multiply this out, you're only going to have an x cubed. So that means we need to repeat one of these zeros. So that means we need to actually add another factor. Now, we could add a factor of x plus 3. Or we could add a factor of x minus 2. It doesn't matter. It just says that we have to have a function with degree 4 that has these zeros. Now, just so that we have smaller numbers, I'm going to pick x minus 1. I'm going to use this one as my repeated 0. So I'm going to use x minus 1 again. So now we could just leave it here. If you want to multiply this out, we can multiply this out and see if we don't come up with a function of degree 4. Now, I would suggest I'm going to bring down the x plus 3 and the x minus 2. I would suggest multiplying the x minus 1 because that means you're going to take x minus 1 squared, or x minus 1 times x minus 1. So if you FOIL this, you're going to end up with x squared, x times x, and then when you multiply negative x and negative x, that's going to give you a negative 2x, and then negative 1 times negative 1 is a positive 1. And then I'm going to actually multiply the x plus 3 and x minus 2. So again, x times x is going to give us our x squared. And we would take a negative 2x, and then here we get 3x. So 3x and a negative 2x would be a positive 1x. And 3 times negative 2 is a negative 6. And then, of course, that has to be multiplied by the x squared minus 2x plus 1. Now, how do we multiply this out? Well, we're going to take and we're going to distribute the x squared to each piece over here. So x squared times x squared is x to the 4th. X squared and negative 2x would be a negative 2x cubed, and then plus x squared. Then we need to come back and we need to distribute the x. So that means we're going to multiply x by each one of these. So x and x squared would be x cubed. And then we have x and a negative 2x would be a negative 2x squared. And x and 1 would be a positive x. And then for our last step, we need to take the -6 and distribute the -6 to each piece. So we would have a -6x squared. -6 and -2x is a positive 12x. And -6 and 1, we're left with a -6. So now all we're left to do is combine our like terms. So we only have one x to the fourth, so I'm going to bring down our x to the fourth, and we can cross that out. And then we're going to look at our x cubed. Well, we have a -2x cubed and a positive x cubed, so a -2 and a +1, so that's a -x cubed. And then we can go to our x squared. We have 1x squared, a -2x squared, so that's a -x squared, and a -x squared and a -6x squared would give us a -7x squared. And then we go to our x term. We have 1x and a 12x, which will become 13x. And then all we have left then is the -6, so we just simply bring down our -6. And here we have our function of degree 4 that has the zeros -3, 1, and 2.